Good afternoon, Eric. All right. Excellent. Thank you, Eric. Good afternoon indeed. Good afternoon, Maria. Awesome. Good afternoon, Claudia. Awesome. Hello. Hello. Okay. Good afternoon, Alexis. Thank you. Awesome. Good afternoon, Maria. Double shot. All right. Awesome. I mean, by double, I mean chat and yeah, you got it. Okay. Good afternoon, Logan. Excellent. Wait, where is Logan? I mean, I hear. Oh, there. Okay. Good afternoon, Pauline. Oh, I got an exclamation point there. I got two videos and an exclamation point. That's and a two avatars, three avatars. Okay. Good afternoon. Good afternoon. Good afternoon, Katie. Awesome. Oh, did I say Paulina? Yeah, did I say Paulina? Good afternoon. Yes. Good afternoon, Katie. Excuse me. Okay, I'm a little under this whole Monday, Tuesday, Wednesday thing is so confusing. All right, we're gonna. Hi, Victoria. Good to see you, or good to read you. Where? Okay. All right, we're gonna. Um, and hello, Shy, and hello, Emily. Okay. Okay. Hi, Victoria. Okay. We're gonna see what it's like when I'm less. I might be forced into slightly less spazziness today because I feel under the weather. So maybe that will make me maybe me being sick will make me almost like normal or like human energy. Okay. Wait, trying to let Stephanie, we're going to try to start at why. Did that work? Wait, did Stephanie come in? What happened to Stephanie? Okay. Okay. So hello, hello. Okay, we are actually we're still doing homework 6. I mean, we're still talking about things in homework 6. Then we will get to homework 7. I'm not assigning another one right now. Until we get to homework 7. Um, um, Someone asked yesterday a very legitimate question. I am too tired and sick to get into a whole discussion about the following right now. But someone asked, good afternoon, Jenna. Good afternoon. Just so that you know, I mean, yes, we have to have an exam somewhat soon. We will not let an exam sneak up and surprise you. We will definitely you'll have at least a week notice, and we always have a practice. We always distribute a practice exam. I think you know that before we have the actual exam, and we talk about it and all this stuff. But just because I know it's there's always like much more of a ramp up to an exam. It doesn't just come out of nowhere. But for planning purposes, it would be unless start tentatively assuming that it would be 2 weeks from today. I'll be more specific about that. And also exams here are take home anyway. So even when I say 2 weeks from today, that's okay. But yes, there won't be an exam next week. I would not do that out of nowhere like that. But right, it is probably fair to assume that the following week, like that it would be posted the 2 weeks from today or something like that. But you'll have time to do it at home. It's not a sit down 1 hour thing or something like that. And but next week I'll start giving you details about it and a practice exam and details. But since someone did ask yesterday, and it is a reasonable question, like start thinking 2 weeks from today is the target date. And I have to look if there's a conflict with organic chemistry or something, like we'll verify as a group. I'm just too tired to get into that whole discussion right now, but that's like just so you can start planning. Okay, I'm going to start. We're going back to homework 6, like I said, but oh, and I can also say that the exam, when we have it, will not cover anything past. Wait, is this true? I'm pretty sure I can say that homework 7 would be the last bit of material on that exam for whatever it's worth. So even if we all right. Anyway, I'm okay. I'm just saying things just so you can, but we'll discuss this more next week. All right. We're going to do a warm up now before we get, I want to make sure we're understanding things. So here is a warm up for everybody to do. In high school, you might have called this a do now. And that is what it is. So you're going to just try, this is like a little practice exercise. You're going to all just try to do it in your own private Idaho right now. And I'm going to ask, once you think you have answers or questions to this, put them for this, do everything in the direct chat, please. If so that everybody can feel like they can think. Here, I'll even write that. Whoop. Okay. Okay. So I'm going to translate. There's going to be a little bit more to this. This is a warm-up exercise. It's not meant to be a trick. It may require a little bit more thought than you think. I'm going to ask a couple more questions about it, but the setup is we're just dropping a rock. It could have been a bolt, but it's a rock. We're dropping a rock from rest. So we're not thrusting it. We're not throwing it. We're not doing a trick. We're not throwing it up. We're just dropping it. And we're assuming we're near the surface of the earth. So anything that you feel, any fact that you feel that you've learned about gravity or free fall, any number that you feel we've been using from lab number 2 or is fair game here. You're expected to know it. So I'll even say, sorry. So it free falls, I should say. It free falls from rest. So anything you think you know about free fall does apply here. The first thing I want to know is how far the rock has gone by the end of 1 second. Now I'm going to ask a couple more questions to you. Again, for anybody just tuning in, you're doing this privately, and then you're going to give me either answers or or comments or whatever in the direct chat. But I'm going to say, well, so the first thing is just how far has it fallen in 1 second? But okay, so first thing I'm saying, and maybe there's already an answer in the chat, and that's great. But I'm going to make this, I'm making this an exercise, meaning it's sort of starting, hopefully, somewhat simple to picture in your head, which doesn't necessarily mean easy, but I'm trying to make it, like not overly complicated. But the first thing I'm saying, you'll notice before I look in the chat, I'm saying first, have the thing fall for just 1 second and predict how far it's fallen in 1 second. And what I'm advising you right here on this page, sorry, I am really tired. Yeah, what I'm doing right here on this page is saying, for some of you, like for many of you, you might get this answer fast. Now, maybe some of you will get it fast and get it wrong. I don't know, but you might get it fast. But I want you to challenge yourself for a moment, especially if you think this is not too hard or too bad. See if you can solve this more than one way. Like, definitely, there is more than one way to solve this. If you just plug straight into an equation, see if you can understand this without the equation. If you're just picturing it in your head, then see if you can find an equation that actually captures this. Like, literally try to think of this from more than one perspective, so that we can start really believing that we have the concepts here, not just algebra. Similarly, if you did plug into an equation, I would suggest to you there might be more than one equation that one might have used for this. So see if you can do it any other equation way. Okay, so that's number one. Again, I'm just asking, and I'm a little worried. Let me see if there's if what's in the chat is an answer. That's great, and I congratulate the person, but I'm not going to respond yet. But if it's a clarification question, I'll answer. Hold on a second. Okay. All right, it's an answer. Okay, so some answers are starting to come into the chat. I'm psyched. That's good. I'm not going to respond to the answers just yet. I'm going to but I'm okay. I'm not going to put answers in the chat. I mean, I'm going to look at the answers. I'm not going to yet tell you if you're right or wrong. What can I say? I will say, no matter what your answer is, please follow my advice and try to get it more than one way. Put it as maybe a check on your answer. I will say that this is not meant to be a trick. It's meant to be practice. But I will say, like many of our problems in homework, the most obvious answer that might jump into a lot of people's mind is not necessarily what I think the right answer. I mean, I can't tell you there's an obvious answer that jumps into a lot of people's minds sometimes. And I don't think that's the correct answer here. But I'm not, that may or may not be true about what's in the chat right now. But I'm going to go on before I evaluate your answers. And this will also help you see if you're on the right page. I'm going to go on and give you a little bit more. Part B, okay, same setup, all the same setup. Now, how far has the rock free fallen at the end of 5 seconds? In other words, at t equals 5. Okay, same instructions as above. Like, if you can do this, do it more than one way. And for this one, like, I think you could do it in equation way. I think maybe you could do it in your head, some of you, so maybe some not. But for this one, I would say add a chart. Well, here, I'll make that part C. Which will really bring us back to, we were in the middle of a chart yesterday in homework 6. We were in the middle of the Edna problem. The truth of the matter is this is basically the Edna problem, just with slightly different numbers. You can look at that one if you want for help, but either way, I want you to make a chart for this, and the chart would be like T. Sorry. And I will start looking at the chat in a second, but the chart would be like. Yeah. And my last column I called Y, you could call it X. I'm calling it Y because I'm picturing something falling vertically. I will also last hint, I'm going to shut up. Sorry. Yeah, last hint, and then I'm going to shut up. I would suggest, however you do this, since we're just looking at something that's falling down, we're not looking at something that's also going up. I would suggest that you make a coordinate system in your mind where the down direction is positive so that we don't have to deal with any negative numbers. But okay, I'm going to now, this is the warm-up question. Oh, well, I made it all one bit. Hold on, I have to add one last thing. This is one. I'll flip the pages back in a second too, and we'll start talking about it in a minute. But since I made one ABC, question 2, especially for those of you who do this fast, for question 2, now say the rock is thrust up at an initial velocity of 50 meters per second in the up direction, okay? I want to know how much time. I'm sorry. I want to know, and this is my last thing. I'm really tired today. I want to know how high does it get, i.e., what's its peak height? How high does it get before it starts falling down? Okay, so these are what, again, I'll turn the pages back if you want to see this. It's 2 questions, but the first one has a number of parts. And this is because we've had like a spotty schedule and stuff. This is all totally like what homework 6 is about. I'm just taking a little interlude here to like practice what we've been saying about what we're in the middle of saying in homework 6. This is all about constant acceleration. Oh, and I should say lastly too, sorry, I am really tired, maybe sick. I'm saying this is like,
okay.
sorry. I'm saying this is all what's happening in homework 6, but there's 2 threads going through homework 6. There's 2 threads. There's the concept of constant acceleration and all the equations that relate to that, which is what this is. There's also the thread of relative velocity, Galileo's principle, which is what we were talking about the last 2 days. Just to be clear, that issue, the issue that we talked a lot about yesterday, the VAB plus VBC equals VAC, that issue is not what this is focused on. This whole problem, this whole warm-up, this is all, just to be clear, this is all according to the Earth reference frame. Like you're standing on Earth. This is all according to Earth. So I'm not asking you to add velocities or switch frames reference or anything like that. Any answers you get here are relative to Earth, and that's fine. So it doesn't contradict anything we said yesterday, but you don't have to focus on that relational stuff. Okay, this is all in the Earth reference frame. Okay, so this is what you do. So this is question 1. It has 3 parts, A, B, C. Hopefully you've been taking notes, so you know. And then this is question 2. You're going to do these all individually right now. I'm going to be looking through the direct chat, and I will try to give you feedback in the direct chat while you go. Okay. And but if there's any obviously if something's not clear, let me know. Oh, can I flip back? I'm sorry. Can I flip back to question one? Yes. I can flip around wherever people tell me while but I'm just gonna keep responding in the chat while I okay. And just keep going. If you once you put an answer in, I'll try to get to it. But wait, what did I just oh, did I just what did I just do? Oh, go back to one. Oh, we're on one. Okay. So again, bear with me. I'm just going through the chat one moment. So if you already put an answer, just keep moving on until you hear something from me. Excuse me. Excuse me. This is great, by the way, guys. Keep it coming. This is I don't this is like productive in a whole different way from usual, I think. Okay, and if I missed you accidentally, wait, I'm still going, but I'm trying to go in order. If I've missed someone, I apologize. I think I missed.
We're gonna go over this, right? Like
Oh,
how
yes.
to do.
Oh,
Okay.
yes. In a minute. I'm just waiting till in the minute I've caught up to all of the direct chats, like the minute like it's settled. Yeah, that's exactly. Yes, I promise. Yes. Totally. Yeah, thanks. Um uh, okay. And we're almost there, I think. But yes, that is yes. But this is good. I know this is like more quiet than our class usually is, but I don't know about you guys, but for me, like seeing all of you do this individual work like this immediate individual feedback to each one of you is like in its own way way more productive than uh me like yelling at the top of my lungs for minutes and minutes. So I know, so you're being patient, all of you, while you're waiting for other people, and I appreciate that. And we'll get done in a second. But yeah, it's great for me to see how much all of you have put in the chat and how much work you've done. So I'm just trying to respond to everybody individually. So almost there. And if I accidentally missed, if you haven't gotten any response from me yet, you put something in a while ago and you haven't gotten any response, you might just copy and paste it and just put it the same thing in again, just because maybe I keep scrolling and there might be something I keep missing. Hold on. Whoa. Almost. Okay, and I'm now at the point I'm just making, if any of you, like if I've responded at least once to you already, if I don't get you a second time, I apologize in advance. I'm not, because now people are like dialoguing, which is great. I mean, it's great, but I want to make sure that I've responded to everybody at least once. And then once I've done that, I'll probably stop and talk about it. But I'm just making sure that everybody's got at least one response. Hold on. Think I gotten everybody once. Wait. No, wait, Shawnee, hold on. Wait, you can't hear. Hold on. Wait, let's stay out of the. Wait, this is all supposed to be in the direct chat. I apologize. Let's keep. Hold on. Yeah, yeah. So, yeah, I didn't say anything but let's keep out of the public topic. Wait. Okay. Oh, good. Oh, thank you for at least one person in the direct chat is telling me whether this is like working for them or not, which I appreciate. Okay. So there is a couple of things in the direct chat where there's a couple of places where I haven't responded to people. Oh, wait. Hold on. I think I'm almost at the point where everybody's gotten at least one response. Hang on ones. Okay. All right. I think so. I'm going to start talking about this now. So a lot of you, not all of you, by the way, this was all private so that like people, because I didn't want, it's harder to think when other people are thinking more loudly, so to speak. So I'm glad I'm looking actually who's here. I would say almost everybody seems to have gotten a chance to think this through and try. And I mean, it looks like almost everybody put something in the chat, and that's great. And if you put anything in the chat, definitely submit. That counts to submit for points and stuff. And if just put it in whatever portals count. Sorry, hold on. Now I'm going to start talking about it now. So there were a lot of right answers in the chat, and there were a bunch of wrong answers also. And there were cases where people put a wrong answer initially and then adjusted it based on what I said. But what some of you saw also in the chat, I was emphasizing like there's more than one ways to do these things. And what I'm really the big lesson in the end, of course, I'm going to show you right now. I'm going to go over it. But well, all right, I'm just going to go over it. But I want to encourage you. I mean, if you think it's hard, then we want to get it right. Like if you got it wrong, like the first goal is to see why it's wrong and see my way of doing it right. But if you think any of these exercises are very fast and straightforward and you're getting them right, then I really want to encourage you to go beyond just plugging and chugging into an equation, especially what we'll see in a second, especially equations that have like squareds in them. It's very easy to trust those equations and plug in without really looking conceptually at what you're doing. And then it becomes a little bit of a coin toss. Like if you're lucky, then you use the equation right. But in other words, you don't just want to blindly use these equations, especially the ones with squares in them. Because then you're relying heavily on something else to do the work for you, and you're turning it into math when in fact there's like a whole physics aspect to this. All right, I'm talking too much. So I want to encourage you guys, those of you who got answers really quickly, if they're correct and you got them by plugging into something with squares in it, really try and step back and see if you can understand why your answer makes sense in some other way. But all right, I'm going to start going over it now. There's something else just happened in the chat. Wait, you still can't hear? Wait, can people hear me now? I am talking now. Can people hear me now? Okay, Claudia can, thank you. Shawnee, if you can't hear, wait, where's Shawnee? Oh, well, that's why she can't. Okay. All right. You can hear. Okay, thank you, Pauline. Okay, you can hear. All right. So, and I don't think Shawnee's here anymore. So that may be why she can't hear. Okay. So, all right. So we're gonna look at going over. All right, so here's the rock. And I'm saying it's free fall, right? And it's free fall from rest. So its initial velocity is 0, right? And I'm calling down positive. And the one thing that I'm going to establish right now, since it's free fall, what many of you right away understood, excuse me, what many of you understood is if it's free fall, then yes, you can assume that if it's free fall, then that means that there is a constant downward acceleration due to gravity, which we can call lowercase g. And yes, as many of you, and we know the number for that, as many of you recognized, the number is approximately something like 9.81 meters per second squared. And many of you use that number. And that's correct. We can't do these problems without a number. Wait, if you can't hear, I don't know what I think everybody else can hear. It may be something on your side, Shawnee, with your device, because I think everybody else can hear. Okay. So it is true. If anybody says free fall, you can assume the acceleration is a constant. You can assume that is the free fall acceleration constant. Yes, that is approximately 9.81 meters per second squared. But please note that's approximate. Even 9.81 is an approximation, like where the digits actually go on forever without repeat. So we are okay. Good. So we're chopping off digits and approximating even when we call it 9.81. Therefore, unless you're told otherwise, or unless you're literally in the lab or doing an experiment where precision measurements really matter, it's very customary. It's very customary for physicists to round that to 10 meters per second squared. There is nothing wrong with, and I'm not saying you're wrong if you leave it as 9.81, but you can make your work a lot easier by rounding the 9.81 to 10, and you're not lying any more than you were lying when you said 9.8, right? So that's a piece of advice. Before I go any further, I'm going to use 10, and on exams and everything, unless otherwise specified, you can use 10. It's a standard physics habit, and it just makes all the calculations much easier to picture in your head, which really is the goal here, to be able to actually believe this and picture that it makes sense in your head. If it does, I'm going to keep going on. But again, just because something works in an equation, if you can't see how it's making sense in your head, or it looks like it's going against the sense in your head, we got to keep thinking until it all matches up. Okay, so if we go to question 1, at t equals 1, how far has it fallen, right? Okay. A lot of people at first, like, they remember the 9.8 number or the 10 number, and so a lot of people at first said, well, according to that number, in the first second it falls, then like 9.8 meters or 10 meters. That's a classic instinct, but this is why we're doing this checkpoint right now. As many of you found out as you thought about it more or talked about in the chat, that's not correct. Like, the answer to question 1, how far this thing falls, is not 9.8 or 10 meters. It is half of that. Okay. So standing back, like if I just drop something from rest in an acceleration, in a free fall, where the acceleration due to gravity is 10 meters per second squared, that does not mean that in the first second something falls 10 meters. It actually means that in the first second it falls 5 meters. Now, why? Okay, many of you saw this by plugging in, many of you plugged into the x equals 1 FAT squared equation. And that's good. That is correct. And that is what the equation is for. So no critique there. That's good. And it's a shortcut. It'll do things for you. But I want to show you a different way. I want you to see why it makes sense. Or put another way, if your head is telling you that the thing should fall 10, if your head's like, well, look, but gravity is 10, gravity speeds up objects by 10 meters per second every second. So my head or my gut is screaming like it should fall 10 meters. But then I do this equation and the equation says 5 meters. Okay, what that means is we have to reconcile those two. Don't just accept the equation on faith and just be like, well, I don't understand what's going on. I'll just trust the equation. Like the equation only works if it actually makes sense. So why does the equation make sense? Here's why, where it came from in the first place. Because it G equals 10 meters per second squared means that at T equals 1, V equals 10 meter per second squared. Let me start with that. What the G number means is not that every second we fall 10 meters. It means that every second we speed up by 10 meters per second of velocity. What that 10 means is at the end of the first second, we have achieved an instantaneous rate of 10 meters per second, not an average rate, an instantaneous velocity at the end of, like, literally at T equals 1, V itself, not average over the span, but V at T equals 1 equals 10 meters per second. That's what the G number means. So if we just leave that as our answer, we have not actually answered the question. Wait, yes, it's okay if you didn't round. That's what I was saying before. Yeah, it's okay either way. But I'm rounding from here on, and I recommend it from here on because it makes it easier. But so the answer, right, is not 10 meters or 9.8 meters. The question's asking how far the thing fell. I don't know that yet. Here's what I know. Right? What I know is that this thing is moving faster and faster all the time. That from the beginning of the first second to the end of the first second, this thing has this rock has accelerated up from rest to a final velocity of 10 meters per second, right? If I were to say, if I want to find out how far it's fallen this time, to find out how far it's fallen, right? What I'm going to put this in equation form in a second. But what I'm saying is, in English, displacement equals average velocity times time. Or put another way, the one original GDP of this whole class is that average velocity equals displacement over time, right? Therefore, displacement equals average velocity times time. When people say, like, in a way, again, I've said this before, this entire class is a big expansion or excuse me, or unpacking of the idea that you've heard since 7th grade, that distance equals rate times time. Everything we're doing here is all about distance equals rate times time. But the big lesson of physics is you got to be really, really careful when you say the word rate, what kind of rate you mean. Distance equals average rate of speed times time. Or put another way, displacement equals average rate of velocity times time, right? like, I'm going to put it one last way. I'm just trying to drum this in conceptually what's going on here, where these squared equations that obviously many of you used, and that's good, but where all these squareds and everything are coming from once things are accelerated is our recognition that we don't want to think this object, I mean, we want to think maybe, but we realize that this object could not have fallen 10 meters in the first second, because that would require, for it to fall 10 meters in 1 second, would mean it was going an average velocity of 10 meters per second for that span of 1 second. And I don't believe this thing was doing that. Like I'm saying, I'm dragging this out because I'm trying to drum in the point. If we believe that displacement, if we believe that displacement equals average velocity times time, then we realize the average velocity is not 10 meters per second. That's an instantaneous velocity that this rock achieved right at the final moment of its first second. It was never going 10 meters per second until that last moment, right? At the beginning, it was going 0. And then it sped up and sped up and sped up. And it did all of these numbers less than 10 until it finally got to 10. So there's no way this rock could have gone 10 meters in the first second. It was never going as fast as 10 meters per second until the very final moment. On average, since acceleration is a constant, we can say that on average, this thing was going at the average of its velocities, right? I'm using that other equation now. I'm saying average velocity by definition is displacement per time. We already know. Therefore, displacement equals average velocity times time. But how do I get the average velocity? Well, in this case, I can get it by averaging velocities. I can say that the mean equals the median. This is one of those times where I can do that because the rate of acceleration, the rate of velocity change is constant. In other words, the average velocity of this thing right? I'm trying to emphasize, and of course I will go on and all that, but I'm literally right now trying to avoid that squared equation. I love it. It's not a problem, but I don't want to just blindly plug into that until I can really see how it is consistent with my intuitive understanding of the physical world. So I'm saying from the beginning to the end of this first second, on average, this rock was only going 5 meters per second. Like it, right? That's because that's the speed it was going right in the middle of it. Started at 0, it built all the way up to 10. So on average, it was going 5. Therefore, how far did it get in that first second? Going back to the equation, it's 5 meters per second times 1 second. And again, if you didn't round, then everything I'm saying you would apply to, you would get the answer 4.9. That's fine. I'm not quibbling about that. I just think it's easier to picture if you don't round. But I'm saying in the end, the reason that the answer to the first question is 5 meters, not 10, is because on average, this thing is only going 5 meters per second. It's not on average going 10 meters per second. 10 meters per second is its final climactic instantaneous velocity. Okay. And I think things are happening in the chat. I'm going to look at the chat in a second. Of course, I'm going to move on too. But if you use that equation, what I want to show you in a second is that equation is capturing all these steps that I just did. It's a faster for sure. So like, yes, once you're comfortable with it, you believe it. Of course, you can use the equation. But please understand the equation is not some magic thing. It's just combining all the steps I just did, well, you'll see. It's just putting them together. But all right, let me just look at the chat for a second before. But this is the answer to question 1 is 5 meters or 4.9 meters. Okay, let me just look at the chat. Okay. No, I see the direct chat things about the devices. Okay. Right. Okay, cool. Oh, and thank you guys who are responding to each other. Like those of you who are helping each other, like whether it's with electronic devices or the rounding, definitely please remember that those of you like Katie, thank you very much. And Paulina, remember, you could submit for points to multiplayer co-op. I'm not trying to, but I really do appreciate that you guys are helping each other, especially while I'm talking. Okay. I mean, while I'm trying to do something else. So, okay, that's the answer to the first one. Now, I just want to show you something. This was an example when those, I know many of, well, okay. So, but many of you did, of course, consider what many of you did was this. Now, again, I'm not disparaging that. It's totally correct. But in it, but you know, really where the equations like that are, well, really what you did actually, let's make this really clear. I mean, really what you did was something like this, right? But then you said correctly, or in your head or something, you said, well, that's 0 and that's 0. So you plugged it all correct. But what I guess what I'm really trying to say is where these equations like this are really useful is when the numbers are really complicated or you have more than one object or something. Like if you couldn't cross out all these zeros and stuff like that, and we weren't just plugging in one, but in a situation like this, in an example of just 1 second, you should be able to check and make sure that your answer actually, that this is spitting out an answer that actually makes sense. What this thing is doing, what this equation is doing. Okay. I just want to remind you that where this equation comes from is just what I just did step by step. Like 1/2 AT squared or AT squared over 2. First of all, where's the over 2 coming from? The over 2 is the whole point I'm making it that you had to, that we're really looking for average velocity here. That displacement equals average velocity times time. So the average velocity is the beginning velocity plus the end velocity divided by 2, right? So that's where that 2 is coming from. And then what's happening is we're just doing what I just did. It's taking the beginning velocity and the final velocity and dividing them by 2, averaging them. But where is it getting the final velocity? Where are we getting the final velocity? What's really happening is in our head, we're saying like the final velocity is 10 because we're using the acceleration rate. Every second, the velocity increases by 10 and it started from 0. So at the end of 1 second, it gets a velocity of 10. So that velocity averaged with the velocity of 0, all multiplied by time, is what you're doing when you plug into this equation. The time is being squared because you're taking into account time twice. One, because velocity times time equals displacement, and the other because to get the velocity in the first place, you have to do acceleration times time. Okay, so I'm just saying, maybe you can start to see that equation isn't, in other words, we didn't pull that equation from nowhere. That equation is just the condensation of this logical thinking. Okay, I'm going to move on to the second way. You can hear now. Okay. All right. But yes, I agree with everybody and I'm psyched. And again, I don't mean to make anybody feel, I'm glad if you did the equation, you got the right answer. Cool. But this is why it worked. Okay. So now I'm going to go on to the next question. Or did I? Yeah, that was right. I think. All right, so then the next question, or part B, question B was now at t equals 5 seconds, what is x, right? Now, I'm going to show you again, to cut to the chase. Okay, again, yes, you can go like this, and many people did, and that's great. For sure, this works. So you get, I mean, and this is all approximate, you get approximately 125 meters. If you use the 9.8 number, you would get something more like 122.5 meters. Either one of those is totally fine. Okay. But I would submit to you, especially if you're getting good enough with the equation that you can do, that you trust this, that you feel comfortable with this, I would submit to you that you guys can actually do this in your head without the equation. In fact, I'm gonna show you, instead of like, watch. Okay. But I mean, that is the answer for sure. But you don't have to use the equation to do that. Try right now. And I'm not going to ask you to put in the chat or anything. Well, you could put in the chat, but I'm not going to like stop and respond to every single one this time. But like x equals 125 meters is the answer to the last one. And most people, by the time they got to this 1B, if they got that far and they were getting correct answers, they were using the equation. That is great. But I bet you, if you stand back and just think about this, you can see how that answer makes sense in your head without plugging into 1/2 AT squared. And I challenge you right now, you can put answers in the chat or not. I'm just going to give you a couple minutes to think. Take that exact same question, and without drawing out a whole chart, without plugging into numbers, can you do it in your head for how far the thing would fall in 10 seconds? Like, try. And again, you could put it in the chat, and you could submit for points. But so I'm just asking, right? And then I'll go back to question C, of course, and question 2. But if you're getting used to this, if you're seeing what I'm saying, that it's really all about using all of our concepts and acceleration and everything to bring it back to good old standard average velocity times time equals displacement. That's the trick here. Like, all of this stuff is just shortcuts that reduces. I see something in the direct chat. Good. The question is whether you did that without the equation or not. I'm trying to ask you to do this without the equation. And I would really recommend rounding here. Now, if you're going to try to do these things in your head, which is the goal, it's a lot easier to picture this stuff if you do round. So I'm going to pause. I'm going to pause until there's a few answers in the direct chat. I'm not going to type in the direct chat, but okay. So try to do it in your head. Oh, I just saw one that came in where the number was definitely rounded, and that is the one that I just saw. Cool. Okay, some of them are very. I see that things are coming into the chat where people are, I think, doing it in their head, or certainly they're rounding, which is good. And I agree with some of them, and one of them I think is definitely the right idea. I'm not gonna, but I'm psyched. I'm gonna wait for one more. But it looks like some of them I think I really do agree with. I mean, I like the approach of all of them. I'm gonna wait. Okay, I just got. All right, I got a bunch in the chat, and I'm impressed. I'm impressed. I'm gonna say this. I think I agree with a lot of what's in the chat. In our heads, we can say x equals 500 meters. And how did I do that? And I agree. Those people said, and people who said 250, that was very good. Oh, good. Someone's saying it makes sense to them now. And 250 was a very good thought too. Like, 250 is not, It's a very smart thought. I think it's 500. And here's how oh, okay, wait. I see why people are saying 250 and more than one person saying 250, but let me caution you on that. That's smart, but I would take it. Okay, the people that are saying 250, it is smart, but let me address that. Well, here, let me write down why. In fact, this is a very good illustration that we'll go move on. Okay, listen. Okay, I'm actually glad, and you should definitely submit. Those of you, and there's more than one of you who wrote 250, you should definitely submit for points for that. I mean, in fact, to be blunt, like even in the, for example, there's many portals you can submit, including the one for wrong answers. 250 is wrong, but it's a very helpful, it's a very understandable and very helpful wrong answer. And I'll tell you why. The reason, and this is not a critique of anybody, this is an explanation of the physics. The reason that people put 250, it seems like 250, I'm sorry. Yeah. The reason that people put 250, the reason it seems reasonable is because the last answer was 125, right? And that was for 5 seconds. So now I've gone to 10 seconds. I'm asking you 10 seconds. So what a lot of people intelligently did is they were like, well, Yaverbaum doubled the time. And he said I could do this in my head. I mean, he said I could just reason this out. So he gave me twice as much time. I'm reasoning it out. I figure it'll go twice as far. That is very good scientific thinking, honestly, or, you know, traditional math thinking. What you're thinking, if you do that, though, if you're thinking that if Yaverbaum doubles the time, then you double the distance, you're then thinking that distance is directly proportional to time. If distance is directly proportional to time, then you're absolutely doing the right thing. And you absolutely do understand direct proportionality. Like if I put distance and time on a graph, if it were a straight line, then you're doing exactly the right thing. But the catch of all of this, and this really is the catch, the thing that we're like really studying right now is distance is only directly proportional to time when the velocity is constant. That's what it means to say displacement equals average velocity times time or whatever. Like you have a linear equation like x equals vt, as long as the v, as long as you have one number for v to work with, whether it's a constant v or you use one average v and pretend that you have one v that's not changing. But you have to have one not changing v for distance to be directly proportional to time. What we're saying here is once there's constant acceleration, once there's acceleration, now it's velocity itself that's directly proportional to time. You'll see in a minute. Like if I double the time, what that means is I double how fast the thing is going at any given, at the final moment. If velocity is directly proportional to time, then distance is directly proportional to the second power of time. Distance is now, when acceleration is constant, distance is directly proportional to time squared. That's where that equation, that's what that equation is really trying to say. Why squareds are coming into it is now we have acceleration. I mean, again, if you're thinking of this in calculus terms, when you have one derivative, then you have a 1 degree polynomial. When you have two derivatives, as we do now, when we have a derivative of a derivative, like, right, acceleration is this derivative of velocity, velocity is the derivative of position. So acceleration is the second derivative of position with respect to time. So position is proportional to the second power of time. Like, and that's why acceleration is measured in meters per second squared. Like all of this is not a coincidence. I mean, I'm not saying it's easy, but I'm saying it does. I mean, it takes some getting used to, But then once you get used to it, it all does fit together, and it fits together with lab 2 and all of that. So what I'm ultimately saying, one way you could do this in your head, if you want, is you could say, oh, if you want to do it the way some people are saying, like, okay, Yaverbaum just doubled the time. Then if you want to do something in your head, one thing you could do is quadruple the distance. You could say, right, because 4 is 2 squared. So instead of multiplying the distance by 2, if you multiply the distance by 4, you get 500. That's the correct answer. I don't know if I'm okay. So that's one thing. Like that's the I'm looking in the yeah, right. Right now, last thing on that, I'm doing in your head, and then I'll go back and finish the thing, and then we'll go back. Like last thing on that is if we're looking at t equals 10 seconds, the way I do this in my head is I say, then final velocity would be like, remember this thing, the one thing I know is the constant acceleration of 10 meters per second squared. This thing gains 10 meters per second of velocity every second. So what I know is at the end of 10 seconds, what I know is that the final velocity is 100 meters per second, right? That's proportional. The velocity is proportional to the time. So I know that if I've given this thing 10 seconds now, it's fallen, its final velocity is 100 meters per second. Therefore, its average velocity is the beginning velocity plus the final velocity divided by 2. In other words, its average velocity is 50 meters per second. 50 meters per second. That's average velocity. So this is equivalent. Now, if I ask how far does this thing fall in 10 seconds? This thing is an object it's equivalent to something that's fallen at an average rate of 50 meters per second for 10 seconds. So it's fallen 500 meters. That's how I do it in my head. But yeah, it all works with the equation. All right, for what it's worth. All right. Now I'm gonna go. Just looking at the time. So, oh my God, it's 1:30. I'm sorry. Okay, I didn't get back to. Wow, I'm sorry. I mean, I'm not sorry. I mean, I think this was productive, but I know we still have to get back to homework 6 and the final answer for the one exercise we didn't go over, and I think the answer to the very last one, just so you know, and we're stopping right here. I didn't realize it was 1:30. Yeah. So the final answer for this is 125 meters. But I'll suggest again to you, we'll talk about it next time. You can get that in your, how did I do that in my head? I didn't plug into any equation. I said, if this thing is thrown up at 50, if it's thrown up at 50, it's going to go till it stops. So it's going to go till it's going 0 meters per second. So on average, it's going the average of 50 and 0. That's 25. So it's going on average 25 meters per second for 5 seconds, because it takes 5 seconds to run out of 50 meters per second of speed if you're losing 10 every second. So in my head, I did 25 times 5. That's where I got 120. But anyway, I'm sorry. All right. So have a nice day. I'll hang out for a second and answer questions. I hope that was helpful. Thank you so much. Thank you so much. Okay. Have a good day. Thank you. And I'll turn off the recording.